Alright everyone, welcome back to the channel. Today we're going to be working inside of this little cure oven. This cure oven is actually from Canada, and the problem with this oven is I don't have any drawings on it. So I'm going to go ahead and open it up today. We're going to take a look at what we're going to have to do, and hopefully it's just plug and play. But we got to see what we got to do to install this solid state relay in here. Now, the thing about this oven, it has a redundant contactor setup. So it goes from one mechanical contactor into a mercury contactor. So we're going to have to eliminate both contactors and install one solid state relay contactor for the heater element or the heater portion of this oven. Now, this oven is used and abused. It does not have any drawings. It was purchased at an auction. It fell out of the sky. I really don't know what the story is with it. All I know is I'm going to be troubleshooting this from the hip today. So we're going to go ahead and see what we can see. Yeah, this oven is going to be a 480 volt. So it's posted right there, 480 volt. But we're actually going to be working out of the control circuit because I just need to find the circuit that is going to turn on this solid state relay every time this oven temperature controller calls for it. That's pretty much it. The thing about this solid state relay is there's no moving parts, and this is actually a three-phase solid state relay, and it's just a lot different than a mechanical relay because the points will not mount, the points will not burn out. This is basically operating off of semiconductors internally, kind of more or less off of a circuit board. And if this is going to be AC, it'd probably be a triac optocoupler. So internally it's going to have a triac optocoupler, and that is the function on the closing and opening. So that is a huge benefit. The other thing is they're quiet and they can switch fast. So they have a fast response time when you're actually calling to close the circuit. The other thing is this one has a little illumination light. So yeah, so we're just gonna go ahead and go with that. Alright, so yeah, like I said before, this has a pretty much redundant contact setup. So I want to go ahead and eliminate both of those contactors, and I want to only run my solid state relay. So the first thing that I'm going to have to do is I'm gonna have to find where the signal is that feeds that contact and where the signal is that feeds that contact. It looks like at some point they were tapped into the same line, which is absolutely redundant. I'm not really quite understanding it yet. So let's go ahead and start making sense of this right now. Alright, so I have my meter and I'm going to get into place, and we are going to be troubleshooting live because I need to figure out where everything is coming from, and I want to see what my signals are doing, and I can see a lot faster with the meter. So we got the meter set up. Let's set it up right here. Alright, so there we go. We're set for voltage AC. So the first contact that I want to see is, I guess, my mercury contactor. So it looks like our mercury contactor is labeled 17, and that one just pulled out. So if I follow it back, it looks like 17 goes into this terminal block, and this terminal block, this one is labeled 17, and it looks like terminal 17 continues through this path. It looks like everything off this terminal block goes into this whip, which heads to our control circuitry, which is our on and off switches and our temperature controller. So I'm not seeing 17. I see number 4, I see number 15, I see 16, I see 5, I see 3, I see 9, I see 4. 4 is our main power. So 3 into there, into 5, and 3 into here, loop to 4, to 4. It looks like the way it's set up right now, since 3 is our main supply voltage, 4, then 4 goes to 9, or 9, okay, and then 2, so it leads into there, something must come back, and 4 is even feeding our temperature controller. So let's see here. So what do we got? So we're looking for 17. I'm sorry guys, I got off track there. Alright, so we got 4, we got 2, we got 9, we got 3, we got 5, we got 15, we got 16, we got 10, and we got 11. I'm actually not seeing 17. Okay, here's 17 right here. The label fell off. Okay, so that is 17. So 17, so that is the heater on switch. The heater on switch. So 17 feeds to this mercury contactor. So let's go ahead and take a reading off of that. So on our mercury contactor, since it is coming off of the heater on switch, it is actually not on a control circuit, on a controlled circuit, on and off circuit, because when this top contactor that feeds it was pulled out, it still had a voltage reading. So every time that contactor pulls out, this contactor should not have any voltage to the coil. So right now we have voltage there. Contactor pulled out, and we still have voltage to the coil on 17. So that means it is wired direct. Power on, always. This one is cycling on and off. And this wire, it is not numbered. Okay, so that one is numbered. That one is off of terminal 15. Right here, 15, 15. So where's wire 15? It goes into 15 into this harness. So here's 15. 15 is coming right off of the temperature controller. So right now, there is no output light on the temperature controller because we are at temp. And our contactor is not pulled in. So we're operating two separate contactors off of two separate circuits, which is not good. We want to isolate both contactors to work off of one circuit, and that's kind of going to be the goal here without a drawing. So it shows our output light is illuminated and our contactor is sucked in. So yes, the mechanical contactor is operating off of the temperature control unit. The mercury contactor is operating directly off of the on and off switch. So that is where we are. So we want them both to operate off of the temperature control unit, so we need to figure out how to do that without a drawing. Here's what I'm thinking. I'm thinking we already know where each one of those wires goes and where it comes from. This contactor comes off of this temperature control unit. That contactor operates directly off of the on and off switch. So I think for the moment, in order for tracing and tracking, I'm gonna do some point-to-point kind of tracing here. I don't need power for that, so I'm gonna go ahead and shut this unit down and lock it out. Now that we have the unit locked out, I just want to do a real quick voltage check on the input voltage, which are these three leads right here. Okay, and we are dead. That's B and C. We are dead. A and C, no voltage. All right, we are good to go. So now that I kind of got that all situated, now we figured out who gets turned on and when and where it comes from. So number 17 is coming directly. I don't want to lose this little label. Number 17 is coming directly off of this wire, directly off of the on and off switch, and comes through. He goes through this whip into that terminal, jumps over to that terminal, and they go straight to our mercury contactor. 15 comes off and operates independently of 17 off of there into the terminal block, and he goes to this contactor, which this is 17 and this is 17, and I noticed that 17 also has a little jumper in it. It has a jumper on this side between 16, because I was looking at 16 and I noticed that 16 had no output. I'm like, okay, 16 is no output, and then I noticed a jumper on it, and I'm like, okay, so 16 and 17 are jumpered, are essentially the same wire. So I asked myself, well, what does 16 go to? And 16 goes to the common on our temperature controller. So 18, 19, and 20 are our common. So 20 is the common, which is wire 16, and wire 19 is our normally open, which is the one that is opening and closing to control our mechanical relay. If that is the case, that means that 17 is feeding the voltage to close that contactor. If I was to take the output of 17, which is this contactor, and just jumper him with the output on 15, they essentially should turn on and off at the same time. So I'm going to go ahead and do that right now, and then we'll power it back up. And I think that will kind of tell us that 15 is the actual controlled wire off of the temperature controller, which we know, and that's the wire that we want. I believe 17 could be eliminated entirely as long as we leave him jumpered to 16. So I'm going to go ahead and do that right now. So I am going to disconnect 17, and we're going to mate those. We're going to let those boys chill together. Here we go. So I will pull him out, and I will put him right there. So yeah, so we're gonna jumper 17 with 15. So now we have 15 going to both. So 15 is controlling 2 relay loads. So let's go ahead and fire this unit back up, and we will see what it does. All right, so we're here back at the unit. Let me go ahead and verify that we have a voltage source. I'm just gonna get my meter, and let's start poking. All right, so we are here. This is our source, and yes, we have 480 volts. So yes, we are live. So now that we have voltage, feed voltage, I'm going to start turning my components on. So there is a fan, recirculation fan. Turn on the exhaust fan, and let me slide on my heaters. Boom. Okay, so our contactor sucked in. So now let me hold this door open, and we're going to start probing out again. So now essentially we have both of our wires coming off of the temperature control unit, and all I want to know is that this coil has no voltage when that contactor pulls out, and then I will know that we have the correct wire in order to wire in our brand new solid state relay, which is going to make this unit a lot more effective and efficient. So it looks like our contactor is kicked in, so we actually have voltage to both of these contactors right now. I want to see when this contactor kicks out if that contactor, the mercury contactor, will no longer have a voltage source. There, it kicked out. So I want to go ahead and take a voltage reading right off of there, and as expected, no voltage, and the contactor pulled in and we have voltage. So yes, we have found the leg that is operating off of the temperature control unit, and we are still using the leg that comes directly off of the on and off switch to provide the source for the normally closed, normally open circuit on the temperature control unit. So we will go ahead and start relabeling these wires and renumbering everything, and then we will just install our solid state relay. So there it is, folks. So that is where I'm pretty much going to stop today. That's kind of where I needed to get today. So there, he kicked out. So if he kicked out, we should have no voltage on this. Exactly, no voltage. Okay, so we're in a good place. So we're ready. So I'm going to go ahead and get some taps ready and prepare to mount that solid state relay. And I will put that on video coming in the morning tomorrow. So for that being said, I'm going to go ahead and cut it quits right there. That's basically part of the process, is trying to figure out the circuit before you actually install the equipment. And that's kind of what we're doing today, is just coming in before to kind of map out the scene before we go into battle. So yeah, that was it right there. So for today, I'm going to go ahead and leave that circuit as is, because we want everything to operate off the temperature control unit. And as I come in tomorrow, everything is already in effect and in place for me. They actually do not need to use this oven for the rest of the night, so I'll leave it shut off overnight until I come in and start to install the new components. So with that being said, I'd like to thank everybody for watching. I really appreciate it. And I hope that somebody out there got something out of this video, or at least a process on how I go about it. And yeah, that's pretty much it. That's how the sausage is made. Every day is different in industrial troubleshooting and industrial environments. So if you are in this environment, be prepared to see something new every single day. And every single day is a new opportunity to learn and to grow. So I'd like to thank everybody for watching, and if you have not yet subscribed, go ahead and smash that subscribe button. It ain't nothing to hit the button. I want to thank everyone for watching. Stay safe out there. Later.